has confirmed it's launched an attack on Iran.
At exactly 2 minutes past 2 in the afternoon, when the heat over the Persian Gulf turned the horizon into a silver haze, a single radar operator aboard a U.S. early warning aircraft noticed something strange. At first, it looked like noise, small flickers on the edge of the radar screen, appearing and disappearing like insects over water. But within seconds, the pattern became clear. It was not noise. It was a swarm. 32 objects were rising from the sea surface, moving fast and low, barely above the waves. Their signatures were tiny, almost insignificant. Cheap composite bodies, small engines, minimal electronics. But together they formed something far more dangerous than their price suggested. A coordinated drone attack. The target was one of the most valuable oil tankers currently crossing the Persian Gulf. Fully loaded, insured for more than $2 billion, and carrying enough fuel to influence diesel prices across 3 continents. If the tanker burned, markets would panic within hours, and the drones were only the beginning. Just minutes earlier, Iranian coastal radar operators had tracked the tanker's course as it passed through one of the most strategically fragile shipping lanes on Earth. A missile battery was prepared. A Noor anti-ship missile, designed to skim across the surface of the sea at nearly the speed of sound, was placed on launch standby. The idea behind the attack was brutally simple. Modern warships carry some of the most advanced defensive systems ever built. But those systems rely on expensive interceptors, missiles that can cost millions of dollars each. What happens when you force those systems to fire again and again at targets worth almost nothing? A drone that costs a few $100s, a missile that costs $2 million to stop it. Multiply that equation by 30, multiply it again by time, and suddenly the most powerful navy on Earth is forced into a dangerous mathematical game. But the Iranians had overlooked something. Far above the Gulf, a U.S. Navy E-2D Hawkeye had already detected the swarm forming. Its rotating radar dome quietly mapped the drones as they spread into attack formation. Every movement was tracked, every signal analyzed. Within seconds, the coordinates were transmitted to an American destroyer patrolling the region. On its deck, the Aegis combat system came alive. Inside the ship's combat information center, screens lit up with incoming tracks. Operators watched the swarm approach the tanker, calculating distance, speed, and interception windows. The drones were still dozens of kilometers away, but closing fast. Firing standard missiles would stop them, but it would also burn through millions of dollars in seconds. So the destroyer did something unexpected. Instead of launching its most powerful weapons, it waited. Because somewhere just beyond the horizon, 2 helicopters were already moving into position. Their weapons were not expensive interceptors. They were something far more dangerous to a drone swarm. Cheap rockets, laser guidance, and a plan designed to turn a cloud of attacking drones into burning debris before they ever reached the tanker. What happened over the Persian Gulf in the next few minutes would become one of the clearest demonstrations of how modern warfare is changing, not through bigger weapons, but through smarter ones. And for the Iranian commanders watching their screens, the battle was about to turn in a way they never expected. The Persian Gulf looked calm that afternoon, the kind of calm that hides how fragile the global energy system really is. Dozens of commercial ships were moving through one of the most heavily trafficked maritime corridors on Earth, carrying crude oil, diesel, and liquefied gas to markets across Asia, Europe, and North America. Among them was a massive oil tanker operated by a Western energy consortium. The vessel stretched longer than 3 football fields and was carrying nearly 2 million barrels of crude oil. In global markets, the cargo alone was worth hundreds of millions of dollars, but the real value was far greater. If something happened to that ship in the narrow waters of the Gulf, the consequences would ripple through financial markets within hours. At 13:58 local time, according to later reports from maritime tracking systems, the tanker was passing through a shipping lane not far from the Strait of Hormuz, a strategic choke point where roughly a fifth of the world's oil supply moves every day. Tankers, container ships, naval patrol vessels, and fishing boats filled the radar picture. From a distance, it looked routine. But on the Iranian coastline, several hundred kilometers away, a coastal missile unit had been quietly monitoring the tanker's course for almost 40 minutes. Iran has long invested in anti-ship missile systems designed specifically for the confined geography of the Persian Gulf. Among them is the Noor missile, a domestically produced weapon derived from earlier Chinese designs. The missile is capable of flying at low altitude over the sea surface, using radar guidance to locate and strike large vessels. Official specifications suggest a range of roughly 120 kilometers, though Western analysts believe upgraded variants may travel even farther. At exactly 1400, according to a reconstruction made later by defense analysts, a launch command was transmitted from a coastal battery concealed within hardened positions along the shoreline. Moments later, a plume of smoke rose above the cliffs as the missile ignited. The Noor accelerated rapidly, climbing briefly before dropping to a sea-skimming trajectory just a few meters above the water. At that height, it becomes difficult for ship radars to detect the weapon until the final moments of its approach. For the crew aboard the tanker, there was no immediate warning. The ship was not a warship equipped with advanced missile defenses. It relied mainly on maritime security alerts and nearby naval patrols. On the bridge, officers were focused on routine navigation as the vessel maintained a steady speed through the Gulf. But something unusual had already begun to unfold in the sky. Roughly 6 minutes before the missile launch, commercial satellites later revealed that several small radar signatures had appeared over the water roughly 40 kilometers away from the tanker's projected route. At first, they looked like fishing vessels or small boats. In reality, they were launching points for a coordinated drone swarm. Iran has developed a wide range of unmanned aerial systems in recent years, including the Shahed family of drones. These aircraft are relatively inexpensive compared with conventional military systems, but can be used in large numbers to overwhelm defenses. According to later intelligence estimates, more than 30 drones were launched in a staggered formation designed to approach the tanker from multiple angles. The tactic reflected a growing strategy in modern warfare, saturating expensive defensive systems with large numbers of low-cost threats. A drone built with lightweight materials and a small engine might cost a fraction of the price of a missile required to shoot it down. In theory, even the most advanced Navy can struggle if forced to intercept dozens of targets simultaneously. Within minutes, the situation in the Persian Gulf was no longer routine maritime traffic. It was the beginning of a complex attack designed to test both military defenses and the stability of global energy routes. If the tanker were struck and disabled, the consequences would extend far beyond the crew on board. Oil traders in Singapore, London, and New York monitor the Strait of Hormuz constantly, because even a temporary disruption can trigger immediate price spikes. Some analysts later estimated that a successful strike on a fully loaded tanker could push diesel prices in parts of the world above $4 per gallon within days, while insurance costs for shipping in the Gulf could skyrocket overnight. What the Iranian planners may not have realized at that moment was that their operation was already being watched. Far above the Gulf, beyond the sight of any ship crew, a radar system aboard a U.S. surveillance aircraft had begun tracking unusual movement over the water. The tiny radar echoes of the drones were faint, but together they formed a pattern that experienced operators immediately recognized. And within seconds, that information began moving through one of the most sophisticated naval defense networks ever built. The concept behind the attack was not built around a single missile or a single explosion. It was built around arithmetic. Iranian military planners had spent years studying how modern naval defenses work, particularly the layered missile defense systems carried by American destroyers and cruisers operating in the Persian Gulf. These warships are equipped with some of the most advanced defensive technologies ever deployed at sea, including phased array radar and vertical launch systems capable of firing dozens of interceptor missiles in seconds. On paper, the system looks almost impenetrable. But the weakness is not technological, it is economic. A single interceptor missile used by modern naval air defense systems can cost anywhere from several $100,000 to more than $2 million depending on the model. Even shorter-range missiles designed to destroy incoming drones or aircraft are extremely expensive because they contain advanced guidance systems, rocket motors, and sophisticated sensors. Iranian strategists realized that forcing a defender to fire these costly weapons repeatedly could create an imbalance that favors the attacker. This realization led to the development of what military analysts call saturation tactics. Instead of launching one or two large weapons, an attacker launches many small threats at the same time. Individually, they may not be impressive, but together they force defensive systems to make rapid decisions about which targets to intercept and how many interceptors to expend. Iran's growing drone program provided exactly the tools needed for this approach. Over the past decade, the country has produced several families of unmanned aerial vehicles, including the Shahed series, which has become widely known in recent conflicts. These drones are designed to be relatively inexpensive to build, while still capable of flying long distances and carrying explosive payloads. Many versions use small piston engines similar to those found in recreational aircraft, giving them a distinctive buzzing sound that has been reported in multiple conflict zones. For this particular operation in the Persian Gulf, intelligence analysts later estimated that 32 drones were launched from several fast boats operating in loose formation across the water. The boats themselves blended easily into the crowded maritime environment of the Gulf, where fishing vessels and small cargo craft are common. From a distance, the launches would have been difficult to distinguish from normal activity. Once airborne, the drones climbed to a modest altitude before spreading out into a coordinated pattern. Each drone followed a slightly different flight path toward the tanker, forming what military planners refer to as a distributed swarm. This tactic makes it harder for defensive radars to treat the swarm as a single cluster of targets. Instead, each drone appears as an individual threat approaching from a different direction. The idea was simple but potentially effective. If the defending naval forces attempted to destroy every drone with traditional interceptor missiles, the cost of the defense could quickly exceed the cost of the attack by a huge margin. Some analysts have pointed out that a drone assembled from commercially available components might cost only a few $1,000s, while the missile used to intercept it could cost hundreds of times more. Iranian commanders believed that this economic pressure could force difficult decisions aboard American warships. Should they fire expensive missiles at every small radar contact? Should they conserve interceptors and risk allowing some drones to slip through? In a crowded maritime environment, even a single drone reaching the tanker could trigger fires, explosions, or catastrophic damage. There was another layer to the plan as well. While the drone swarm approached the tanker, the anti-ship missile launched from the Iranian coastline would close in at high speed. The swarm's purpose was not only to attack, but also to distract and overwhelm defensive sensors. Radar operators would suddenly be faced with dozens of incoming objects moving at different speeds and altitudes. In theory, this confusion could reduce the chance of detecting the missile until it was already dangerously close. Some reports later suggested that Iranian engineers had even programmed certain drones in the swarm to behave differently from the others. A few were set to climb higher than the rest, briefly exposing themselves on radar screens before dropping back down toward the sea. This behavior may have been intended to mimic the flight profile of larger aircraft or missiles, forcing defensive systems to analyze each signal carefully. Inside Iranian command posts monitoring the operation, confidence reportedly grew as the drones spread across the Gulf and began closing the distance to the tanker. On their screens, the swarm looked exactly as planned, dozens of small moving points converging toward a single target. What the planners could not see was that the same swarm was also appearing on another set of radar displays hundreds of kilometers away, inside the airborne surveillance aircraft quietly watching the entire operation unfold. By the time the drone swarm had crossed the halfway point toward the tanker, the situation had already shifted from an isolated maritime incident into a complex military engagement unfolding across several layers of technology and command networks. High above the Gulf, the airborne radar platform that had first detected the unusual movement continued to track the formation with remarkable precision. Aircraft of this type are designed specifically for early warning and battlefield coordination, carrying powerful rotating radar arrays capable of detecting aircraft, missiles, and even small aerial objects over vast distances. What initially appeared as scattered signals now formed a clear tactical picture. Dozens of small aerial vehicles advancing toward a vulnerable commercial vessel, while a separate high-speed track moved across the water at low altitude. The information flowed instantly through secure data links connecting aircraft, warships, and regional command centers. Within seconds, the radar tracks were transmitted to a U.S. Navy destroyer operating several dozen nautical miles away. Inside the ship's Combat Information Center, a windowless room glowing with screens and tactical displays, operators began watching the situation unfold in real time. The destroyer's combat system, built around the Aegis Integrated Defense Network, automatically started processing the incoming data. Its computers compared radar signatures, speed patterns, and flight behavior with an enormous database of known threats. Almost immediately, the system flagged the swarm as a coordinated attack pattern. At the same time, another set of alerts appeared on the tactical screens. A fast-moving contact approaching just above the sea surface matched the flight profile of a sea-skimming anti-ship missile. Sea-skimming weapons are notoriously difficult to intercept because they hide in the radar clutter created by waves and reflections from the water's surface. In some cases, a defending ship may detect such a missile only when it is tens of seconds away from impact. Inside the combat center, tension rose quickly. The destroyer carried powerful defensive weapons capable of intercepting both aircraft and missiles, including medium-range interceptors and shorter-range systems designed for close protection. In theory, the ship could destroy every approaching drone with these weapons, but doing so would come at a steep cost. Each interceptor carried in the ship's vertical launch system represented an expensive and limited resource. Warships cannot simply reload missiles while at sea. Every launch must be considered carefully. This is where the economic dilemma of modern defense becomes painfully clear. An attacker using inexpensive drones can create a situation where the defender must choose between spending vast sums of money on interceptors or accepting the risk of letting threats slip through. Military planners sometimes describe this problem as cost asymmetry, where the defender spends far more resources to stop a threat than the attacker spends to create it. The operators in the combat center were well aware of this reality. Destroying dozens of small drones using high-end missiles would technically solve the immediate problem, but it would also burn through a significant portion of the ship's available interceptors. In a region where tensions could escalate rapidly, that kind of expenditure might leave the ship vulnerable later. But the destroyer was not alone. Several miles away, two naval helicopters had already lifted off from a nearby vessel and were flying low across the water. The aircraft were MH-60R Seahawk helicopters, a platform widely used by the U.S. Navy for maritime patrol, anti-submarine warfare, and surface surveillance. While they are not normally the first system people imagine when thinking about air defense, these helicopters carry a surprisingly flexible range of weapons and sensors. The pilots had received the targeting data through the same secure network linking the surveillance aircraft and the destroyer. On their displays, the swarm appeared as a cluster of moving symbols slowly spreading across the Gulf. The helicopters adjusted their course, climbing slightly to gain a better view while remaining outside the range of any potential small arms fire from vessels below. Instead of expensive interceptor missiles, the helicopters were armed with something far simpler: laser-guided rockets based on the Hydra 70 system. Hydra rockets themselves are not new. The basic unguided rocket design has existed for decades and has been used by many militaries around the world. What changed in recent years was the development of guidance kits that can be attached to the rocket, transforming it into a precision weapon known as APKWS, or Advanced Precision Kill Weapon System. The guidance kit contains small control fins and a laser sensor that allows the rocket to steer toward a target illuminated by a laser designator. Compared with sophisticated interceptor missiles, these rockets are extremely inexpensive. They were originally developed as a way to give helicopters and aircraft the ability to strike small targets accurately without using large guided missiles. In this situation, they offered something even more valuable: a way to destroy drones without spending millions of dollars per shot. As the helicopters approached engagement range, their sensor operators began identifying individual drones within the swarm.